I am going to cover the topic of model interpretability. We only have a short amount of time, so I will first explain what model interpretability is, why it matters, then how models are made interpretable, techniques used to make models interpretable, and some real-world applications of model interpretability. What is it? Model interpretability is the ability of a human to understand the decision-making process of an AI model. An interpretable model provides predictions that are easy to comprehend. Why does interpretability matter? It is necessary to understand why a model is performing and predicting the way it does. An interpretable model is intrinsically more accountable than a model that is not easily understood. Accountability is important when a model has direct effects on people. Accountability goes hand in hand with legal compliance to ensure that a model is ethical, builds trust among users of the model, and finally, interpretable models are important for bias detection and to ensure fair and transparent decision making. How are models made interpretable? Models can be interpretable in different ways. The model itself is interpretable and easy to understand. An example of this could be a simple linear regression model. Methods within the model, like the weights and structure, are understood well. The whole model could be interpretable, or specific individual predictions can be understood. Results of the model are understandable through feature summaries, feature visualizations, learned weights, data points, and approximations. Okay, key techniques for model interpretability. I have highlighted a few key techniques to aid in model interpretability. The first is feature importance, which identifies key predictive factors in a model's decision. Then we have SHAP values, which stands for Shapley Additive Explanations. This assigns important values to each feature of the model to describe its impact on predictions. An example of this is that it can be used to explain how patient characteristics affect disease prognosis. Then we have LIME, which stands for Local Interpretable Model Agnostic Explanations. This simplifies complicated black box models into interpretable explanations for each individual prediction. And then we have saliency maps, which highlight the most relevant regions in the data. This is often used in image analysis. This can also be used in medicine for screenings of cancer. And then we have anchors, which are simple and understandable rules to explain individual predictions in classification models. Some real-world applications of why interpretability is important. Healthcare, model interpretability is necessary for explaining diagnostic decisions when an AI model is used for doctors and patients. Transparency, understanding, and fairness of a model is extremely important, and I'll spend a little bit more time talking to this one given the class. But machine learning algorithms are often used to make diagnoses for support treatment planning in life or death situations, like within the field of oncology. Ensuring that an algorithm is interpretable is necessary in guiding patients and doctors through decision making. Additionally, metrics other than just accuracy start to play a bigger role when talking about large populations or rare diseases. And these metrics need to be considered, and what they mean and how we got to those metrics needs to be understood well. And then some other applications that I'll highlight are credit scores for self-driving vehicles. The algorithms need to be understood to build public trust. Human resources algorithms need to be understood to help prevent bias and ensure fair decision making. And finally, um, The takeaways here are that model interpretability is an important part of being a good data scientist, and the context of the model is important in deciding what methods to use to create an interpretable model. Thank you, and I'll be happy to answer any questions.